Generally, we are having two types of governors, centrifugal governors and inertia governors. So, in our laboratory, we are using a centrifugal governors only. Centrifugal governors means the force it is acting from the center of the axis to outside. It means that became a centrifugal type of governors. So, in this type of universal, this is universal type of governor. So, at a type of governor itself, we can use more than 3 types of governors. Based on the sleeve, based on the arm, we can change the different types of governors. So this is the speed measurement systems. So here this is the sleeve, this is the ball, this is a spring loaded governor. So governors, two types of governors. Generally we are differentiating through the specifications. This is the spring loaded governor. Unspring loaded also we are having. Without the springs also we are having. Based on this is the speed measurement systems. This is variac. This is the motorized part. So based on that speed, so the sleeves it is possible to move from this area. So suppose in this type of this is the universal governor I already told you. Based on the changing of sleeves, this is sleeves, this is the ball. From the center of axis, based on the center of the axis changing, we can in this experiment itself we can set 3 types of governor. For example, here itself we can set Porter governor, Proel governor, Hartnell type of governors also. This is Hartnell type of governor. So now we are going to measure the distances from the center of the axis to this distance, from this sleeve distance. So initially what is the point we are having? So ultimate aim of this experiment, we are going to find out 2 concepts. One is speed, second one is sensitivity. Right? So what are the different types of load we are going to give? What is the speed variations? That is also we are going to find out. Sensitivity also. Sensitivity generally we are mentioning into the S as in speed already we know as a n point. Both we are going to find out. Speed also we are going to find out. Sensitivity also we are going to find out. So now I am going to apply the load now slowly. So this is ball radius. So in this each and experiment I already told Porter type of governor, Proel type of governors. In this type of governors also we are changing different types of balls. So this is the rotating part. So actually in the part, one more information I want to tell to you. In the part of governors, so all the type of transportations we are using into the governors. Governors actually it is a speed bus. So it is used to control the speed. So if you want to increase the speed, if you want to reduce the speed, both we are using into the governor only. So it is controlled the speed. So now, so the sleeves it is moving from there. So that is a increasing of speed. Based on that, the sleeves it is moving from the center of the axis to balls it is possible to move rotating high speed. So from the initial position to top positions we are finding the speed. Right? So this is the rotating part. So I already told you this is the spring loaded type of governors. Give more speed. Actually in the part, the top surfaces only we are going to set into the accelerator pedal. So it is so only it is telling we are considering as is speed bus. So this is sensor. Just so in the part, so here we are measuring into the speed 280 to 345. So which one? So now we are setting 453.7, 490 is the 0.4 is the speed of this experiment. Based on that we are going to find out the angular velocity also. By using n is equal to 2 pi n by 60 we can find out the angular velocity. Sensitivity also, yes. So I already told so in this experiment we are going to find out the sensitivity and speed of this governor. So this is the formula to find out this rotation. So this is the ball radius, x is the displacement, a is the height from the point to the center of the axis to this height, b is the radius from the center of the axis to this distance. So generally it is a common distance. Speed already, sensitivity, this is the formula to find out this. N1 minus N2 by N. So N is equal to N1 plus N2 divided by 2. That is N value. N, so initial position speed, and N2 it is a higher position. The effort is equal to S1 by S2 divided by 2. S means that is a sensitivity. So here this is the initial speed, motor speed. We have taken 500 into 700. So based on that speed, we are going to find out omega is equal to 2 pi n by 60. This is initial. Omega 1 is equal to 2 pi n by 60. N is equal to speed. From this value we are going to set. So we are getting into the radians per second. Height, so already I told you know, from the 120 into 130, that is distance. Both distances we are taking. So from this equation we can find out this alpha also. Height from this h is equal to, this is a L is equal to length, total distance length from this distance to this distance. L is equal to total distance length, that is 120. So alpha is equal to cos inverse of 120 by 180. We are getting this value. So this same value from here also. So that is radius of rotation by using this formula, r is equal to r naught by r naught plus x into a by b. So from this equation, r naught, it is a ball radius. This is the ball. This is the ball radius. So generally 14 mm radius we are having. So I already told you. So in this experiment, this is a Harnell type of governor. Porter type of governors means we are going to replace different types of balls radius. The sleeves also we are going to set different types of length. Like that Hartnell, Proel, Porter, Watt governor, all the type of governors, the sleeve length it is to be changed. So this ball radius also possible to change. This is, so that is a different from each and every experiment. And one more information I told you know, loaded governors. This is spring loaded governors, and without spring also we are having another experiments also. This is also another differentiation into the governor type of. So governors, it is very important. It is used to control the speed of all the automobile sectors. So from this equation, finally we are going to find out the force. So force is equal to F is equal to m into omega square r. M into omega square r. M is equal to mass. It is a common ball mass. Omega, from this equation we are going to take omega is equal to 2 pi n by 60. That is r is equal to, from this equation, r is equal to r naught by plus x into a by b. This is the values already, a and b. A value, it is the distance from this distance. From b it is the distance center point to the total distance. By using that you can find out this r value. Substitute the value from here. F is equal to m into omega square into r. M is equal to mass, omega is equal to angular velocity, r is equal to radius. So by using that force we are going to find out. So and then one more information from this sensitivity, that is I already told you know, sensitivity n1 minus n2 by 2. Omega is equal to 2 pi n by 60 now. From this equation itself we can find out the n1 value and the n2 value. So that which n is equal to, capital N is equal to n1 plus n2 by 2. So we are getting into the capital N sensitivity. This is effort is equal to S1 minus S2 divided by 2. Sensitivity, that is effort is equal to S1 minus S2 by 2. S1 is equal to spring force maximum speed, that is 2 FCL B by A. FC1 means centrifugal force. I already told you know. So in this concept of this force, all the governors, it is a centrifugal. By using the centrifugal force only, it is acting. Centrifugal force means the force it is acting center of the axis to outward directions. So that is at N1, what is FC1? That is we are taking from this speedometer. That is FC2 also we are taking to the speedometer. Substitute this S1 minus S2, we can get into the effort. That's all. Thank you.